We're still going to be using some of the series tests that we have been talking about. Today we're going to apply them to figure out the interval of convergence. So if I give you a series, we're going to try to figure out what x values you could plug in where the series would converge. We're going to be using mostly the ratio test today. There is one more terminology. I just want to show it to you real quick. If you have a series that looks like this, or like this, and they're going from 0 to infinity, these are called a power series. If you ever hear the word power series, it's a series that looks like that form. You could also have like other variables, like the an could include factorials, it could include negative ones to the n's, but it's basically a series that's multiplied by x to the n or x minus c to the n. Just wanted to show you that vocabulary. Now, we're going to start with a problem like this. And the question is, what values could I plug in for x that would make this series converge? So, you're going to start off by using the ratio test. You're going to plug in your n plus 1 for your n's. So n plus 1 is n plus 2. Normally you would times it and flip it, but since it's just one thing, we can just divide it. Alright, if I think about the factorials, think about what will cancel, you'll end up with an n plus 2 on the top, and then if you subtract exponents, you end up with an x on the top as well. Alright, we're trying to find the limit of this as n approaches infinity. Well, if I plug infinity right there, I've got infinity plus 2 times x. X is just going to be considered a number because we're going to be looking for x. So this limit is infinity. What that means is that this series diverges, because the ratio test says if you get a number greater than 1, that the series would diverge. So this one doesn't have an interval of convergence. It doesn't converge anywhere, it always diverges. Okay, we're going to do this one similarly. Plug in your n plus 1s. Alright, the 4's will cancel. You can subtract exponents, so you get x minus 2. And what we know about the ratio test is that this will converge if absolute value is less than 1. We know that for the ratio test, that whatever you get has to be less than 1. It's an absolute value. And so in order to find this interval of convergence, what we're going to do is we're going to solve that equation. And basically what you do is you put negative 1 around the x plus 2 and the 1. This is how you solve this inequality. You just put a negative 1 less than x minus 2 less than 1. You add 2, except you add it to all the places. One plus 2 is 3. And then you end up with this interval. And what this says is that if you pick any number between 1 and 3, that when you do the ratio test, you would get something less than 1. Now, when you get your interval of convergence, you also have to check the endpoints. I'm going to do that on a separate sheet of paper, or in a separate slide. So we know that we're going from 1 to 3. And we know that the original series was this series here. So what you do is you plug in x equals 1 and you plug in x equals 3 and you look at the series that you have. Alright, so I end up with 4 times negative 1 to the n, and here I end up with 4 times 1 to the n. Alright, then you have to determine, do these two series converge or diverge? If they converge, then you would add equals under here. If they diverge, then you wouldn't, because you would say that at those two places that the series would still diverge. So 4 times negative 1 to the n, if I wrote that out, if I plugged in a 1, I get negative 4, plug in a 2, and so on. This is a diverging series. And you can just look at it and tell that no matter what I'm doing, I'm continuing to go up. There's not really, it's not geometric, it's not a p-series, there's not a way to explain that except to look at those numbers and to realize that depending on where you stop, this is going to diverge. Over here you get 4 plus 4 plus 4, that will continually go to infinity. If you want to say that's the nth term test, we can. Sometimes it'll be easy to tell why it converges or diverges. The first one was kind of hard, but this one diverges as well. So this is your interval of convergence. Now, we also have something called the radius of convergence. And the radius of convergence is half the distance between it. So if you think about this, this is going from 1 to 3. So the distance between 1 and 3 is 2. So the radius of convergence is not 2, but 1. Because it's like just thinking about where the center is. The center of this would be 2. And then so 3 is 1 away from 2 and 1 is 1 away from 1. If you wanted to do 3 minus 1 and then divide by 2, you could get that as well. So the interval of convergence is this thing, and the radius is this. Basically, that's the two things that we're looking for here, is the interval of convergence and the radius of convergence. So similar type of problem. Let's look at the interval and radius of convergence. Well, we would start off by plugging into n plus 1, n for n. So that would be 2n plus 2 minus 1. Because you've got to multiply that n plus 1 out. So that's 2n plus 1. And then we're going to times it and flip it. I'll just go ahead and separate it while I'm at it. Alright, subtract exponents on the x. So 2n plus 1 minus 2n minus 1 comes out to be 2. Same thing for the 5. And again, we want this to be less than 1. Now this one is kind of different. You get x squared is less than 25. And you just have to think about what happens with squares. But that means that x is going to be between negative 5 and 5. And I think that makes sense. So then you're going to check to figure out what's going on at negative 5 and 5. So I'm going to plug in a negative 5 for x. I get negative 1 to the 2n minus 1. And then I'm going to plug in a positive 5 for x. I get 1 to the 2n minus 1. Again, both of these diverge because we're just changing from 1s to negative 1. So there's no equals on the thing. This is the interval, and the radius would be 5 because the middle would be 0 and then the distance from there would be 5. Okay, so here's another one. Start off with the ratio test again. Flip it. Subtract exponents on the x. And then you have n plus 1 over n plus 2. Remember, we're trying to find the limit as n approaches infinity. And x is kind of like a number. So this would be x. Alright, we want the absolute value of x to be less than 1. So we're going to end up with this interval. Negative 1 is less than x is less than 1. But then we need to check the endpoints. So let's let x be negative 1 and let x be 1. Plug them in. 1 to the n over n plus 1. Excuse me, negative 1 to the n over n plus 1. And then 1 to the n. 1 to the anything is still just 1, so we're going to put 1 over n plus 1. At this point, if you can look at it and tell what's going on, you don't have to do the whole process. But this one will converge by alternating series. It's an alternating series, and I can look at it and tell the numbers are going to be less each time, and the limit's going to be 0. This one is going to diverge. It looks like a P series, 1 over n. And so if I compared it to DCT, or you could say LCT, then it would diverge. Now, because I have converging on this one, that means I have to have it equals on my interval. So this is the interval of convergence. My radius of convergence is going to be 1, because the distance from the middle is 1. Okay, so here's another example. Again, we're doing the ratio test. Remember, with the ratio test, it's absolute value, so I don't have to worry about the negative. Go ahead and put in your n plus 1s. Alright, m plus 1 will be left on the bottom with our factorials, and there'll be an x on the top. Remember that you're finding the limit as n approaches infinity. Think about x as a number. The bottom has the biggest power because we're talking about n. So this is 0. Well, since that's always less than 1, this always converges. Which means if you want to write an interval, you can say that the interval of convergence is negative infinity to infinity. And as far as the radius of the convergence, the radius would be infinity as well. So it's possible that you can go back and problems like number 1, the series could always diverge because you don't get a number less than 1. It could be problems like 2 or 3 or 4 where you get an interval and you have to think about whether it converges or diverges at the endpoints. Or it could be like number 5 where it always diverges. Alright, here's your 2 try problems. Sorry, it's 3 try problems. But they're all very similar. Using the ratio test, find the interval and find the radius of convergence.